them together. So that's when we use the word sum, S-U-M. Now, if I use the word product, the product of 6 and 7 is 42. So how did I get 42 using 6 and 7? I multiplied 6 times 7. So when we use the word product, we associate it with multiplication. And when we use the word sum, we associate it with addition. So let me give you another pair of numbers. Let's have 10 and 4. The sum of 10 and 4 is 14. 10 plus 4 is 14. The product of 10 and 4 is 40 because we've multiplied 10 times 4. So be very careful when you are using those two words in mathematical terms. S-U-M, sum, product, P-R-O-D-U-C-T. Sum is linked to addition and product linked to multiplication. So that's a nice way to start the lesson, actually. That's a nice way to start the math show, because these two words, I hear it every day. Oh, I did some sums last night. Or a parent will say to a child, did you do your sums for homework? I understand why they're using that, which makes sense. But in the mathematical context, the real correct, accurate mathematical context is when we are looking at pairs of numbers or more, and we're adding them together to get the total, and that is the sum, and we're going to multiply to them together to get the product. So I hope that that little introduction is clear, and that you now understand the difference between sum and product. Right, division. Now, I know a lot of you do not like division. Some of you like short division using the bus stop, but when it comes on to long division, when you're taught to do it using factors or using chunking method, that's where some of you become disillusioned with division, especially long division. Now, I happen to like long division more than short division, because short division using the bus stop is relatively quite straightforward. You take each digit in turn and you see how many multiples of the outside number can go into that particular number underneath the bridge. Right, so when you have got a division question, there are 3 parts to the division question. So you've got the number that you are dividing into the whole. You've got the number that is the whole amount that you are going to divide it by that number. And then whatever your answer is, you've got the answer. Now, in mathematics, we've got specific words for each part of that division. The number that is on the outside of the bus stop, the number that you are going to use to divide into the whole, is called the divisor. D-I-V-I-S-O-R. It's called the divisor. Now, the number that the big amount, the total amount that you are going to share by the divisor is what we call the dividend. That is the whole amount. That is the total amount. So you're dividing the divisor into the dividend. So if, for example, you've got a short division question, 64 divided by 5, you're looking at the divisor is 5, that's on the outside of the bus stop. How many times can 5 divide into 64? 64 is your dividend. 64 is your whole amount, your total amount. And whatever the answer is, it's going to be about 12 point something. Whatever the answer is, that is what we call the quotient. So let me go through these 3 words again. The number on the outside of the bus stop, the number that you are going to use to divide into the whole, is called the divisor. D-I-V-I-S-O-R. The dividend is that total big number that's on the inside of the bus stop that you're going to share using the divisor is called the dividend. D-I-V-I-D-E-N-D, dividend. And whatever your answer is, that is what is called the quotient. Now, the quotient is the same as the word result, it's the same as the word answer. But in the world of mathematics, that is the correct vocabulary, that is the correct word to use. So we've had divisor, the number on the outside of the bus stop. We've got the dividend, which is your total amount on the inside of the bus stop. And then you've got your answer, which is called the quotient. So I'm painting a mental picture for you so that you can see the three parts to a short division or long division, and it makes more sense to you. So far we've had sum, product, dividend, divisor, and quotient. Now, those 5 words are important words. They are really important words. But can you see just from those 5 words how much mathematics has opened up? There's a lot of maths. I've got a list here of mathematical vocabulary, mathematical words. I could be here all night going through each of them. So I'm just being very careful to choose the ones that are the most common ones, the ones that you use every day at school or home, and the words that mean a lot to your mathematical understanding, so that you can use those same words with your answers, your explanations, and your reasoning as well. The next word is, one of my favorite, because when I was growing up, when I was younger, I always heard these particular words, and I didn't know what they meant, and I didn't have a clue what they meant, but I kept hearing them being used in the secondary school, especially with the older children. And these words were, the first one was variable, and the second one is coefficient, to do with algebra. There we go. So let me explain in a nice, friendly, easy to visualize, to picture way. Imagine you've written down the number 3, and then you've written the letter X next to it. So you've got 3x. What that really means is 3 lots of X. X can be an unknown number. So let's just say, for example, X has got a value of 2. 3 times 2 would be 6. Okay, so X is our unknown number, and it's next to the whole number. So 3x. And remember, in mathematics, when you are writing the letter X, you do not write it like the letter X in the alphabet, because then it becomes confusing. You do not write the letter X like the multiplication symbol, because that can be confusing. But you write the letter X where you've got 2 letter C's joined back to back. That's what that letter X looks like, okay? So the letter C, 2 of them, and they're joined together back to back. That's what the letter X looks like in algebra, in mathematics. So 3x means 3 lots of X. So in algebra, in between the number and that letter X, you have got an invisible multiplication sign. But we don't put the multiplication sign in the question like that, because it does become confusing. You need to know that it is there. And that's why I called it the invisible multiplication sign. So 3x means 3 times x. Now, the number 3, the number that comes before the letter, is called the coefficient. And the letter x that I used is called the variable. So the coefficient is always the number that goes before, in front of the variable, and the variable is the letter that I can use in algebra. I could have used 3y, I could have used 3t, I could have used 3w, I could have used 3p. Each of those letters that I've just called out is what we call the variable. I can vary the letter of the alphabet that I want to use. So now you can see where the word variable comes from. And the word coefficient just means how many lots of that variable have you got. So 3x means I've got 3 lots of the variable x. If I've got 12x, I've got 12 lots of the variable x, and so on. So that is how exciting it is when you are working with vocabulary, especially when it comes to mathematics, because each part of the question, each part of the number means something. And what you are doing is you are making your maths come alive. And that is what the math show is all about. It's about making maths come alive. It's about making number come alive. It's about making you come alive when it comes to maths. And you know, I'm sure you're gonna say to me that you get questions and you don't know what the question means and you can't answer the questions. Listen, I've been there before, and that is fine. Okay, I've been there before, and that is fine. There are questions that I, Mr. Numbervator, cannot answer. There are questions that if I go into a university and I look at and I sit down, I can't answer the math question. I went to a university where they teach aeronautical engineering, and in engineering there's a lot of maths. And I sat in on one of their aeronautical maths lessons. I did not have a clue what to do. There were equations all over the place until one of the students sat down next to me and explained what to do and how to do it. And the minute the explanation was there, I found it so easy. Now, I'm not saying I can fly an aeroplane or take one up into the sky, because I'm a long way away from that. But what I am saying is that it now makes sense why pilots need to be amazingly good at mathematics. They need to think really, really quickly, because that can affect the course of action, and that can affect how the plane is flying when you're up there in the sky. So maths is a very important subject. Right, so we've had sum, product, dividend, divisor, quotient, variable, and coefficient. So what I've done there is I've crossed over the key stages, because we use the word sum and product in the primary school. We used dividend, divisor, and quotient in the primary / secondary school, and then we use the word variable and coefficient in the secondary school. So I've crossed over the age phases, the age ranges, and the key stages as well. And that's what makes maths so exciting, because it allows me to be able to do this. It allows me to be able to cross over year groups and even cross over individual abilities. But let's move on. There's so much more to do. My next word is polygon. Polygon. P-O-L-Y-G-O-N. Polygon. So, what is a polygon? Well, before I get into the explanation of what a polygon is, let me just give you a little bit of background, a little bit of history to the word, so that when I start to explain what it means, you will have a much better, deeper understanding of a polygon. Polygon is from the Greek language. And polygon, there are 2 parts to it. Poly, and then G-O-N, gon, is from the word gonia, but it's shortened to gon, because it wouldn't sound right, polygonia, okay? So we call it polygon. Right, poly in the Greek language means many. Poly means many, P-O-L-Y. Poly means many, okay? Poly. Gon, G-O-N, is from the word gonia, and the word gonia in Greek means angles. Now, you can only have angles when you've got straight lines. So a polygon is a shape with many straight lines, and the lines are all closed. That means there are no gaps in between the straight lines. So for example, A hexagon is an example of a polygon because it's got many sides and it's got many angles. And the sides are straight. Okay? So the word polygon is a shape with straight sides and many angles. Examples of a polygon could be a quadrilateral, triangle, so that's 4, 5 pentagon, 6 hexagon, 7 heptagon, 8 octagon, 9 nonagon, 10 decagon, 12 dodecagon. So these are all examples of polygons. And what I've just read out to you, what I've just said to you, these are all shapes with straight sides, many angles. This is what makes a polygon a polygon. Isn't maths exciting? Yeah, I can tell that some of you are writing these words down. I've had one comment from a teacher who has just said that, even though she's not teaching in Key Stage 3 or 4, just hearing and knowing about the word coefficient, it's made her understanding of maths so much richer and so much deeper. Now, isn't that a nice message? Okay, this is what the maths show is about. Okay, it's not about what you cannot do, it's about what you can do and how to make yourself better. That's why I enjoy the math show. Okay, so yeah, we've had those words: sum, product, dividend, divisor, quotient, variable, coefficient, and polygon. But here's this next one is one of my all-time favorite words in maths, okay? And the word is composite. Yep, the word is composite. C-O-M-P-O-S-I-T-E, composite. A composite number is a number that is opposite to a prime number. So let's take a step back and let's think about what is a prime number. A prime number is a number that can only be divided by itself and 1. So, for example, the number 2. 2 can only be divided by 2, and 2 can only be divided by 1. The number 2 is unique because the number 2 is our only even prime number. Not a lot of people know that, okay? The number 2 is our only even prime number. So let's look at our next prime number, 3. 3 can only be divided by 1 and 3 itself. So it's only got 2 factors. A composite number has got 3 or more factors. And that's what makes it a composite number, because it hasn't got 2. If it had only 2 factors, it would be prime. It's got 3 and more, and that's what makes it a composite number. 360 is a highly composite number because it can be divided by many, many other numbers, 2, 3, 4, and so on. Okay, 24 is a composite number because 24 can be divided by 1, I have to think about that, 1, 2, 3, 4, 6, 12, and 24. So that's what makes it a composite number. But if I said the number 13, 1, 3, 13 is a prime number. Why is it a prime number? It is a prime number because it can only be divided by 1 and the number 13 itself. So that is the difference between a prime number and a composite number. Okay, now we're going to have a really, really quick short ad break. And then when we come back, I'm going to start off with one of my favorite mathematical words. And that is, what is a perfect number? Yeah, what is a perfect number? And then another one of my favorite words is commutative. Yep, commutative. So we're going to start off part 2 of the math show with the words prime number, with the word commutative, and with the words perfect number. So don't go too far, a quick drink, and I shall see you shortly.
Whether you need to read up on the highway code, or want to book a driving test, whether you need to plan a journey, or find where to park with a blue badge, Direct Drive is the website. Go to www.sovereigncomics.co.uk and get your latest issue of Mr. Numbervator's Max comic book series today. You are now tuned in to the Mr. Numbervator Show every Wednesday from 5:30 to 6:30 p.m. on Tokyo Community Radio Station. Let's get mathematical.
Hello and welcome back to part 2 of the math show with me, Mr. Numbervator, on Chalk Hill Community Radio Station. I just want to play the little last advert that you just heard about the Numbervator show, because that was recorded by Paul Nelson, and Paul Nelson is the third piece in Sovereign Comics. So there's Dean, myself, and Paul. And Paul is the third jigsaw puzzle part, and it's just the way that his voice, and it's just the way that he's just talking about the math show with Mr. Number. So I'm just going to play it again just for you to listen once more.
You are now tuned in to the Mr. Numbervator show every Wednesday from 5:30 to 6:30 p.m. on Churchill Community Radio Station. Let's get mathematical.
Isn't that lovely? So yes, it is me, Mr. Numbervator, on Chalk Hill Community Radio Station, and every Wednesday between the hour of 5:30 and 6:30, it is the math show. And on the math show, it's everything to do with maths. You could be a young person, you could be someone who's doing a degree at university in maths, you could be a parent, a teacher, a head teacher, you could be a school inspector, you could be a government minister. The math show is aimed at all of you, basically. Okay. My number, if you want to call in, or you want to send me a message, or you want to ask me a question, 07535 644 850. 07535 644 850. So back to mathematical vocabulary on the math show. Here we go. Right. The word that I want to start off with is, what is a perfect number? Now, not a lot of people know about this. Not a lot of people know what a perfect number is. I've heard people talking about natural numbers. A natural number is 0, 1, 2, 3, 4, 5, 6, and so on. I've heard people talking about cardinal numbers, but a perfect number, let me explain what a perfect number is. I'm going to take the number 28. I've just taken that number at random, and I'm going to explain what a perfect number is using the number 28. I've taken the number 28, and I'm now going to write down the factors of 28. So the factors of 28 are numbers that can divide equally into 28 with no remainder. So 1, 2, 4, 7, 14, and 28. So I've written down the factors of 28. 1, 2, 4, 7, 14, and 28. Now, a perfect number is where you have got, when you add up all of the factors of 28, but not including 28. So you add up 1, 2, 4, 7, 14. Those factors will equal 28. Now, isn't that amazing? Let me say it again. I've taken the number 28 as an example of a perfect number, okay? I've written down the factors of 28. The factors of 28 are numbers that can divide equally into 28 with no remainder. So I've got 1, 2, 4, 7, 14, and 28. Each of those numbers can divide equally into 28. Now, not including the number 28 itself, if you add up all of those other factors, it will make 28. So 14 plus 7 is 21, 21 plus 4 is 25, 25 plus 2 is 27, and 27 plus 1 is 28. So 28 is an example of a perfect number. But why don't we have some fun, some more fun on the math show? I'm going to choose another number to see if it's a perfect number. I'm going to choose the number 12. I am now going to write down the factors of 12. 1, 2, 3, 4, 6, and 12. Okay, so 1, 2, 3, 4, 6, and 12. These are all factors of 12. Each of those numbers can divide equally into the number 12. So not including 12, let's add up the other factors. 6 plus 4 is 10, 10 plus 3 is 13, 13 plus 2 is 15, and 15 plus 1 is 16. So therefore, 12 is not a perfect number. So what you can now do is you can experiment, you can investigate what other perfect numbers are there. And this is what makes maths so exciting. This is what makes maths so interesting, and it makes maths just so, it makes it, it's like the awe and wonder of maths, because you're thinking, how can you have perfect numbers? Yeah, how can you have perfect numbers? But I've just proved it to you. Okay, I've just proved it to you. So, you know, it's so interesting. Okay, it is so interesting. And perfect numbers, I'm going to give you, you know, for example, 6 is a perfect number. 6 is a perfect number. I'm going to write the number 6 down, and I'm going to write down the factors of 6. So 1, 2, 3, and 6. So those 4 numbers, they can all, each of those can divide equally into 6 with no remainder. Now, if I add up those factors, not including 6, not including the number itself, if I add 3 plus 2 plus 1, guess what I get? I get 6. So 6 is an example of a perfect number. So perfect numbers, we've got 6. Then the next one after 6 is 28. Then the next one after 28 is 496. That would be the next perfect number. And I know you're sitting there thinking, why do I need to know about perfect numbers? Well, when you are solving some algebraic questions, when you are doing quadratic equations, when you are doing simultaneous equations, you need to know about perfect numbers, because perfect numbers can help you to arrive at your answer. So don't underestimate the value and the purpose of a perfect number. So I really hope that everyone understands now what a perfect number is. And the first 3 perfect numbers are 6, 28, and 496. Okay, so these are all perfect. Those are the first 3 perfect numbers. Okay, brilliant. My next word is commutative. Commutative. C-O-M-M-U-T-A-T-I-V-E. C-O-M-M-U-T-A-T-I-V-E. So what does this word commutative means? I'm going to explain it to you using the multiplication tables. If I have got 3 times 4 and I swap the digits around, I get 4 times 3, don't I? And 3 times 4 is 12, and 4 times 3 is also 12. That is what commutative means. But I have been doing some investigations. I've been doing some problem solving. Commutative works with the multiplication tables, but it can also work with percentages. Yes. Listen to this one. 50% of 20 is 10. 50% of 20 is 10. 20% of 50 is also 10. Now, isn't that interesting? So I've just turned the question the other way around, and I've got the same answer. This is what makes maths so magical. And this is what makes the math show so exciting and magical. I'm going to say it again because I know that Dean's in the studio. I can feel him looking at me. 50% of 20 equals 10. That's correct, yeah, because 50% is half. 20% of 50 also equals 10, because 20% is 1/5. And 1/5 of 50, or 50 divided by 5, is 10. So 50% of 20 is 10, and 20% of 50 is also 10. Now, you're thinking, how does that work with mathematics? It's not a trick. I've just done it in front of you. But this is the teaching, this is the understanding, and this is the learning that I want you to get from the math show. The math show is not just a show where I talk about maths, I interview some young people about maths. It's the quality. It's the quality of what you are getting on the math show every Wednesday. And I might use a young person as my vehicle to teach that quality, but it's the quality of what you are getting on the math show. That is what makes the math show so much different to all the other shows. And that's what makes the math show unique. Because where else are you going to find out that 50% of 20 is the same as 20% of 50? Where else would you? But now you know it. By commutative, okay? It means that you can swap the digits around and you can get the same answer. So we've looked at sum, SUM, product, dividend, divisor, quotient, variable, coefficient, polygon. We've looked at commutative, we've looked at perfect numbers, and we've also covered prime numbers and factors. The numerator. Where do we find the numerator and where do we find the denominator? When we are using fractions, we need to be able to identify which part of the fraction is the numerator and which part is the denominator. So I'm going to make up a fraction. I'm going to write 5/6. So 5 is at the top of the line and 6 is underneath the line. The numerator is the 5. The denominator is the 6. The denominator is telling me the total number of parts to divide my whole up into. So if I've got 30, then I'm going to divide it into pieces of into sixes. So I'm going to have 5 lots of 6s of 30. Now, the 5 at the top is telling me how many of those 6 equal parts will I take. And I can do that using a rectangular bar, and we call that bar modeling, or I can do it using a circle, half and half and half again, and I can show it visually what it actually means. So the numerator is the number of parts that you're going to take from the whole, which is the denominator. So if I've got 5/6, 6 equal parts, I'm going to take 5 of them. And that's what numerator and denominator means. And I know I've just said the words very easily. That's because I've been saying it for a very, very long time, okay? And I know some children find it hard to say denominator. I've heard some really exciting, weird ways of saying denominator, but never mind. I know what that means. They mean denominator. But it's a tricky word, but you've got to use it often. So that was numerator, the digit or number above the division line, and then you've got your denominator, which is the number underneath. So keeping in with fractions, what is an improper fraction? Now, I always teach it like this. When you are at home and you are behaving properly, your family's happy with you and you get a nice treat. If you are behaving improperly, you get sent to your bedroom. So I'm just giving you an example of how to understand those two words. Proper, improper. A proper fraction is one that I just gave to you, 5/6. The numerator is smaller than the denominator. If you have got an improper fraction, let's say 12 over 5, so 12 is the numerator and 5 is the denominator, it means that the numerator is bigger than the denominator. So that's what makes it an improper fraction, because it does not look like a normal fraction where the numerator is always smaller than the denominator. For example, 3/4 or 1/2 or 2/5. That's what an improper fraction is. Now, a mixed number. Now, this has caused a lot of issues, especially with parents of a certain age, because when we were younger, we called them mixed fractions. But we do not use that phrase anymore in the school classrooms. We use mixed numbers because a mixed number is made up of a whole number and a fraction bit. So for example, if I have got 3.5, 3 is my whole number and the half is the fraction. You've put them together, you've mixed them together. That's what a mixed number is. And in another lesson, I'll be showing you how to change an improper fraction into a mixed number. Really exciting. Mathematics is very, very, very exciting because the words are all linked together. They're all linked together. There's a phrase in mathematics that I've seen written in some GCSE papers, some year 9, some year 7, some year 6 papers. And this is what we call find the difference between. Whenever you see that phrase in maths, find the difference between, you just think of subtraction. So if I said to you, find the difference between 13 and 9, you would do 13 take away 9, so the difference would be 4. So find the difference between 13 and 9. I could have had 9 and 13, doesn't matter. You're just finding what is the difference, what is in between the two numbers. So that's what it means. It means subtraction. So when you see that written in maths, find the difference between, you're simply going to subtract the smaller from the bigger, and then you're going to get your answer. Do you know what? I could be here all evening just talking about mathematical words, but I haven't got all evening. But what I have got is the enthusiasm, it's the passion, it's the excitement, it's the awe and the wonder behind maths and number. What is it about maths and number that excites me every minute of the day? What is it that excites me every minute of the day? Yeah, and that's what I mean by maths and number. That is what makes maths so exciting. And that noise that you just heard, by the way, was a little block that fell off one of the tables on the floor. So don't worry, there's no injuries, nothing's happened. Right, okay. Another word is arc, A-R-C, not A-R-K as in Noah's Ark, where the animals went in 2 by 2. It's arc as in a section, a part of a curve. So imagine you've got a circle, and where do we learn about arcs? When we're looking at circles, when we're looking at circumference, diameter, radius, chord, that's when we need to know about the arc, because the arc is a section. It's a bit, it's a piece of the whole curve, the whole circumference. So you imagine a circle and you put 1 point on the circle and then you put another point on the circle. The gap in between those 2 points that you've just put on there, that is what you call the arc of the circle. So it's really easy. When I'm teaching, I'm painting a mental picture of the arc. I said to you, draw a circle. put a mark on one part of the circle and put a mark on the other part of another part of the circle. And in between those two marks that you've drawn, that is the arc. It's a section of the curve. It's a section of the circumference. That is what the arc is. Okay? So yeah, it is really, really exciting when it comes to maths. So Dean's in the studio. Dean, are you enjoying listening to the definitions of these words?
Yes, as always.
As always, yeah. And has there been a word that you've been really particularly interested or pleased with? Because I know I've done quite a few. I've done sum, product, dividend, coefficient, polygon, prime, commutative, perfect number.
I like when you said what the children call a denominator. The non-denominator.
Yeah, denominator, and that is very true. And even when Dean was saying it, that the way Dean said it, I've heard it said by some children as well. It's not that Dean doesn't know what the word is, but if you're young and you've seen the word, but you haven't maybe heard the word, and you're going to read it, you're going to try and say it from what you read, it could come out in quite a funny word, okay? But it is denominator, D-E-N-O-M, denom, min, I-N, ator, A-T-O-R, denominator, okay? So syllables, denominator, 5 syllables, denominator, all right? That is what makes maths so special. That is what makes maths so special. And even as I was talking, I mentioned radius, I mentioned diameter, I mentioned circumference, I mentioned chord, C-H-O-R-D. These are all math-specific words to circles. So within the dictionary of mathematical vocabulary, you've got sub parts of it. So you've got topics like circles that have got their own unique vocabulary. Diameter, radius, circumference, tangent, chord, sector. This is what makes maths so exciting. An integer is any whole number, but an integer cannot be negative and it cannot be a decimal or fraction. Okay, so an integer cannot be a decimal or fraction. It can be negative, but it cannot be a decimal or fraction. It's any whole number, and that is what an integer is. Integer, I-N-T-E-G-E-R. Some other words that I've got written down, because we've been through quite a bit. I've got the word mode, mean, and median. And that is when we're looking at averages. And, so averages, if you play a sport, if you play for a team, how many points have you got, do you get after each match? You add them all together and you divide by the number of matches you've played. That will give you a rough estimate. That will give you an average of how many points that you are getting each match. So you've got mode, mean, and median. When you've got a set of data, when you've got some data, some information, you might have a series of 10 numbers, for example. Within those 10 numbers, you might have 3 that are the same. So that means they are the most common. They are the most popular. That's what the word mode means, M-O-D-E. It's the number that comes up the most often in a series of numbers. Mean is what I've just read out to you. You'd add up all of those numbers that you've got, and then you would divide by the numbers, by the total of those individual numbers. So if you've got 10 numbers, you've added them up, and the answer is 70. You'd then do 70 divided by 10, and so on and so on. Now, the median, I'll come on to in a minute. There's another one that I didn't include, but I'm going to include it now. It's called the range. And the range is the difference between the smallest number in your sequence and the biggest. So the difference between the smallest and the biggest is called the range. So now you can see there's the connection between the word range and find the difference between. Isn't it amazing? Isn't that amazing? Very quickly, the median. So what you would do there to work out the median is that you'd put your numbers that you've got, the series of numbers that you've got, you put them into ascending order. There's another word. Ascending means from small to big. You arrange those numbers into ascending order, and then you put one finger on the first number, your other finger on the last number, and then you come in number by number until you're left with one number in the middle, or if you're left with two numbers in the middle, you'd add them together and then divide by 2. That is what the median really basically is. Okay? Now, at the beginning of the show, I was smiling and beaming, and I said to you, I'm so happy because I'm doing what I love to do. It's the end of the math show. I have to stop this. You know, there's another presenter coming on with another amazing show. So can I just say thank you to listeners for tuning in. I know there's a lot of you watching live, the live broadcast that Dean is streaming. Thank you for listening in. Thank you for the messages that you've been sending me, the thumbs and the balloons. I look forward to seeing you and working with you next week. I really hope you've enjoyed the math show today, every Wednesday between the hour of 5:30 and 6:30. It's me, Mr. Numbervator with Sovereign Comics, and it's Chalk Hill Community Radio Station. Have a great evening. Work hard at school. If you've got any questions that you want to ask me, 07535 644 850, or contact me through sovereigncomics.co.uk, because that's our platform. So Sovereign Comics, all one word, SOVEREIGN comics, COMICS.co.uk. Have a great evening, a great weekend, and I look forward to seeing you all next week. Thank you very much, and goodbye.